All right, class, today we are going to be doing our notes for multiplying decimals. Go ahead and turn your page over from yesterday's. Today we're doing page 28. Go ahead and put that in the corner of your page. Okay, I'll give it the title of Multiplying Decimals. Write it in your nicest handwriting, please. Okay, we kind of talked about this a little bit in last notes, but we're going to write down the same thing that we did yesterday. It's very important that you remember that when multiplying decimals, okay, skip a line, I want a little star there to remember this. When multiplying decimals, multiplying decimal numbers, ignore the decimals at first. So we're just going to multiply like we usually would and kind of ignore those decimals at first. Now, that doesn't mean ignore them the entire time. Okay, after we're done multiplying the numbers, so after multiplying, count the decimal places. So count the decimal place values in the factors. Now the factors are what you multiplied together. Okay, your answer will have the total number of decimal places. Okay. So you guys did learn this in 5th grade, but it's been a long summer, so we wanted to make sure that you remember this. Okay, we're going to do a couple of examples. First of all, we're going to practice multiplying with whole numbers. And I want you to think of money. You go to the store and you're going to buy 3 giant candy bars that cost $1.79 a piece. So we're going to do $1.79 times 3. So 3 big large candy bars at $1.79 a piece. How much is it going to cost? We could take and we could add $1.79 plus $1.79 plus $1.79, but multiplication makes that a little faster on us. So remember how I said ignore the decimals at first? So I want you to write 179 times 3. So 9 times 3 is 27. Regroup 2. 3 times 7 is 21. Plus 2 is 23. Regroup 2. 3 times 1 is 3. Plus 2 is 5. Now, how many places do we have behind the decimal in our original problem? We have 1, 2. So we need to have 1, 2 places behind the decimal in our answer. So for those 3 candy bars, without tax, of course, it's going to cost us $5.37. Now, when you're doing whole numbers, remember that you only have a decimal in part of it. But when we multiply a decimal times another decimal, then it actually can make the number smaller, which sounds weird when you're multiplying because you always think the number needs to get bigger. But when you're doing multiplication of decimals less than 1, so let's do an example of this. I know you guys all can agree with me that 0.5 is the same as 1/2. So if I take 1/2 and I'm going to times it by another familiar decimal to you, 0.25, that's 1/4, right? So 1/4. So what I'm saying here is I'm doing 1/4 of 1/2. Now, if you're thinking in pictures, if I have half a candy bar and then I take 1/4 of that half, am I going to end up with something larger than I already had? No, it's going to be a portion of a small portion already. So let's go ahead and do this and see what kind of answer we get. Now I said ignore the decimals at first, so we can write it as 25 times 5. So 5 times 5 is 25. Regroup 2. 5 times 2 is 10. Add the 2, so 12. So right there, it looks like you got 125, but now we have to keep in account how many places behind the decimal we have up here. We have 1, 2, 3 places behind the decimal. So I'm going to have 1, 2, 3 places behind the decimal here. And I need to put a 0 here to remind myself I have 0 whole units. Now you guys can all agree with me that 1/10 is far smaller than 5/10 or 2/10. So see how my number got smaller? That happens when we multiply two decimals that are smaller than 1. And how do I know they're smaller than 1? Because this is 0 and this is 0. Less than 1 whole. Now what happens when we multiply two numbers? So anytime you multiply by a number that has a 0 in my ones place, it's going to be, your answer is actually going to be smaller than your biggest number up here. Now these ones are both larger than 1. So that's why our number actually got larger. Okay, let's practice one where we have one smaller than 1 and one larger than 1. So skip one line and I want you to write the problem. 2 and 36 multiplied by 0 and 0.8. So 800. Okay, remember this is smaller than 1. This is 800 of 1. So this is going to end up being smaller than 2.36. Okay, so ignore the decimals at first. All right, 236 multiplied by 8. So 8 times 6 is 48. Regroup 4. 8 times 3 is 24. 25, 26, 27, 28. Regroup 2. 8 times 2 is 16. Plus 2 is 20. Now, how many places do we have behind the decimal in this number? 1, 2, 3, 4. So that means I need 1, 2, 3, 4 places behind the decimal. So I'm going to put a decimal there and remind myself that I have 0 whole units. So my answer is actually 2,088 10,000ths, which is a pretty small number. Okay, let's try one more example. I want you to write 0.65 times 1.4. Okay, ignore the decimals at first. So we have 14 times, oops, I meant to write that one on top, 65. But in multiplication, it actually doesn't matter which one we write on top. Division and subtraction are different in that, but multiplication can be mixed. Okay, so we do 4 times 5, which is 20. Regroup 2. 4 times 6 is 24, plus 2 is 26. Okay, remember your 0 placeholder, just like in normal multiplication. Now we're multiplying the tens place. I need to put that 0 there to remind me I'm in the tens unit here. So 1 times 5 is 5. 1 times 6 is 6. Now we add that together and we end up with 0 here. 11, regroup 1. 1 plus 2 is 3. 3 plus 6 is 9. How many places do we need behind the decimal? 1, 2, 3. Oh, I'm sorry. 1, 2, 3. So we need 1, 2, 3 places behind the decimal. I still want a 0 placeholder. Now, if you ever have more place values that you need than numbers you have to keep going and you'll have a 0 in that place. Okay, But here's just examples of multiplying decimals.